So this is 3.13. We're doing polars with complex. Here we go.
Previously, we have written complex numbers using the form a plus bi, where a and b are constants. A complex number can be understood as a point in the complex plane and can be determined by its corresponding rectangular or polar coordinates. When the complex number has the rectangular coordinates ab,
Yeah.
it can be expressed as a plus bi.
All right, fantastic. So if we truly understand this, we should be good to go. A represents our what point? Our x or our y?
Dx.
The x. And so the b represents the what point?
The y.
The y. And so when I put it in this complex form, it is the x plus the yi. All right? Does that make sense? So if we can truly understand that, this should be pretty easy. All right, keep going. You're doing great.
The complex number 3 plus 2i can be represented as a point 3, 2 in the rectangular coordinate system. Earlier in these notes, we learned that x equals r cosine of theta and y equals r sine of theta. Using these identities, we can also express a complex number in the polar coordinate system. When the complex number has the polar coordinates r of theta, it can be expressed as r cosine theta plus I r sine theta.
All right, fantastic. So x is equal to what? R cosine theta. All right, and so we already knew how to use that. And so if we truly understand that a represents our x, and x is equal to what? R cosine theta. And then it's in the form of a plus bi, and b represents the what? The y. And what does y equal? R sine theta. And so that's all we're doing, really. And we're just kind of converting between the polar modes and rectangular to polar. All right? All right, let's do this. David's going to read example 6. Here we go.
A complex number is represented by a point in the complex plane. The complex number has a rectangular coordinates -2, -2. What is the only way to express a complex number using the polar coordinates are complicated.
All right, fantastic. So what was given to us? -2, -2, right? And so in this one, we need r cosine theta, r sine theta, yes? And so there's 4 of them. One is x equals r cosine theta, and the other one is y equals r sine theta. But what were those other 2? X squared plus y squared is equal to what? X squared plus y squared was equal to r squared. And that other one was what? Tangent theta is equal to y over x. And so we need to get to the r cosine theta thing and r sine theta thing. All right, so we need our r and our theta. All right, so let's do our r first. And so what's my x? -2 quantity squared plus my y of -2 quantity squared is equal to r squared. So -2 squared is 4. 4 plus 4, which is 8. So 8 is equal to r squared. So r is equal to 2 square root 2, that's fine. All right, we can call that. All right, so we got 2 square root 2. That's cool. And so now let's get to theta. And so we have tangent theta is equal to y over x. So tangent theta is equal to what? -2 over -2, a.k.a. what? 1. And so when does tangent equal 1? Happens twice. When does it happen? Pi over 4. When else? 5 pi over 4. And so now you just guess. Just kidding. Which one is it? Which one do we want? We want the 5 pi over 4. Why do we want the 5 pi over 4? Because it's in the third quadrant. Now, let's put it in our form. And so our x, or our a, is equal to what? R cosine theta. And so now we'd end up with 2 square root 2, that's fine. And then cosine of 5 pi over 4. And then plus I, and then what's my y?
-2.
2 square root 2, and then what? Sine of 5 pi over 4. All right? And so a lot of the times when we do these on multiple choice questions, this will be our answer. That will be our answer. All right? A lot of times that will be my answer. Now I want to prove to you why it will be my answer. So let's do it. And so then let's evaluate. So what is cosine of 5 pi over 4? Negative square root 2 over 2, right? And so now I'd have 2 square root 2 times negative square root 2 over 2, right? and then plus I, and then again, what is the sign of 5 pi over 4? Negative square root 2 over 2. Well, what happens? What do I get? What happens to my 2's? They cancel. What happens when I have a square root of a square root? Those things kind of cancel the square root. So what am I left with? Negative 2 plus I, and then times what? Negative 2. Now, this should not surprise us at all. Because what does A represent? A represents my what? My x. Well, what's my x? Negative 2. And then B represents my what? My y, which was what? Negative 2. Do you see how this was already done before we did anything? All right. And so this is our complex form of it. However, a lot of these will be in this polar mode giving like this. Make sense? All right, cool. Let's keep moving. So example 7. I need another good reader. Ella, thank you so much for volunteering.
A complex number is represented by a point in a complex plane. Using polar coordinates, the complex number can be described as 4 cosine of 7 pi over 6 plus I times 4 cosine of 7 pi over 4 sine of 7 pi over 6. Express the complex number using its rectangular coordinates x, y.
All right. So now we're given this, and this is my what value? So this 4 cosine theta represents our what? Our x. All right, so now we need to figure out what our x is. And so now x is equal to what? 4 times, what's my cosine of 7 pi over 6? Good. All right. And so now when we work that out, we'd end up with, what happens to my 4's and my 2's? Those cancel to be what? 2. So now I have negative 2 square root 3. And so then my y value would be what? 4 sine of 7 pi over 6. So now it's 4 times, what is the sine of 7 pi over 6? Negative 1/2. So now I'd end up with negative 2. All right. And so now my ordered pair xy is actually what? Negative 2 square root 3 comma negative 2. And so there is my complex number in rectangular coordinates.